Saxon Advanced Mathematics, lesson 94. This is a lesson we've been looking forward to quite some time. I mean, I have for sure. I think you probably have too, because we're going to unravel some mysteries about tangent. But first we're going to talk about secant and cosecant. We haven't graphed them before. We've graphed sine and cosine, and we call them sinusoids, right? But those are pictures of our sine function and our cosine function. But we haven't talked about secant and cosecant. They're reciprocal functions, right? Secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. Opposite first letters, right? That always helps me remember. Now, I'm going to show you the picture in the book because that's going to help us a lot to unravel these. Look at just this top part. There, I covered it up. Write the equations of these two trigonomic functions. What the heck? We have these weird U things that fit in between every 180 degrees. This one, they have complete U's. This one's kind of like a broken U, right? There's half of it, and then we have the down, and then we have the other half of the top. How on earth can we possibly know what these are? This looks really hard. Well, it is. But I'm gonna show you a really fun trick to make it easy. What if we, and you can sort of see in pencil I did it, what if we look at kind of like the ghost sinusoid that lives in here, if we drew where the extreme points of the U were the extreme points of the sinusoid. So what if it went like that? Okay, I'm gonna draw it in just a minute in my book. But do you see how I'm kind of drawing a sinusoid in between these wacky function curves? And the same thing here, high point of what's here, or the extreme point of what's here equals the extreme point of my sinusoids. And that would allow me to draw a sinusoid in between these curves. That is the secret to these problems. And the way I recommend you do them in your homework is get a pencil that erases well and have a nice eraser on hand and just draw right in your book. Don't bother copying this all over. That's a lot of drama. And that's what I would do too, but I want you to be able to see it a little bigger. So I'm gonna redraw it myself. But just draw the sinusoid right in here with a pencil in your book and then erase it when you're done. And that's a much easier way to work these problems. Okay, but I'm going to draw. So here's the first one. You get to draw with me. This is our y-axis. And we have a center line. And 1, 0, 1. Okay, that's nice. I'm going to make mine fairly big. I don't want to squish. Makes it harder to see. Okay, this says 90 degrees. This says 180. This says 270. This says 360. Okay, I'm getting unit circle vibes. I know that the points on our unit circle relate to this. So I'm sort of getting my head wrapped back around the trig here. At 90 degrees, this one's at its lowest point, and then it goes up like that. And then here, 270, it's at its highest one, so it goes like that. Okay, 360, and then it says theta. Okay, so what I'm doing is I'm taking this, which is what's in the book, and then I'm going to use another color pen to draw the sinusoid that this is implying. That's a high point, that's a low point. So I know I'm going to be going like this, right? So I'm going to be coming up, I'm going to touch it, and then I'm going to be going down to touch that one, and then I'd be going back up to touch the next one. Now, if I can write the sine, the equation of this sinusoid, the red one, that is going to get me 99% of the way to the green one, okay? So we look at this and go, well, what the heck is going on with our red curve? Oh, it's so familiar. Look, it's coming up out of 0, and then every 90 degrees, it's taking a turn. The red one, I'll just make it go like this so I can write by it. This is y equals the sine of theta, right? That's easy. We know that That's the sine curve, and there's nothing fancy about it, right? The amplitude, the center line, the phase, the period, everything looks really standard. And so what that tells us is that this green function is the reciprocal of sine. So y equals the cosecant of theta. This green thing that I drew here, that's the cosecant function. Who would have ever known? But so cute and so easy, right? That we can just squeeze that little ghost in. And then the second part of A, let's draw that one. Y, and then we have 1, 0, minus 1. And then again, we have this time John has put dots on different places to help us see it differently. This time, the dots are at 90 and 270, and in between we have 180 and then 360. And this is all, I'm just copying this out of the book. This is at 1 and it goes up, and then this is at 1 and it goes down. These all have arrowheads. I didn't draw all the arrowheads. And then this, at 360, this goes up again. Okay? So once again, we see, all right, that is a reciprocal function. P.S., spoilers, whenever we have these upside down U's, that we know it is secant or cosecant, all right? We're gonna see tangent and cotangent in a minute, and we're gonna see they have a different shape. So we know that sine and cosine have this nice rolling sinusoid. Secant is the U's upside, secant and cosecant are the U's upside down, and then tangent and cotangent are third shape. All right, so we're gonna do the same thing we did here. The extreme points of our green function are gonna be the extreme points of our orange function, and then we're just gonna draw a nice smooth sinusoid in between. All right, so our orange curve, we see that's cosine, right? It starts high and it goes down. So y equals the cosine of theta, and then that tells us that the green is y equals the secant of theta, right? And we remember, so that's the basic, that's the lay of the land, you guys. That shows us the cosecant and the secant curve. We remember, though, that sine and cosine, we can write a sine curve as a cosine curve, or we can write a cosine curve as a sine curve, right? Just by adjusting the phase angle. We can do the same thing with these two. We can write them as each other if we want to. But honestly, that's dramatic. We don't need to get into all of that, okay? So this is the basic look of the secant and the cosecant curves. This is cosecant, this is secant. The secant one is the one that splits. Cosecant is the nice U's. Okay, now we're gonna do it again, only this time we have ever so slight variations. This, by the way, was 94.1. And there were two parts of it, an A and B. So this is example 94.2. I'm gonna slide this up a little. Try to keep it out of the shadows. And again, we have two pictures, so I'll draw them individually. Again, I highly recommend you just work these in your book by using a pencil and a good eraser. All right, this time we have a little bit of drama. Notice that our center line is still 0, but our amplitude has changed a little bit here. And here we go. Still just drawing our picture, 90, 180, 270, 360. Okay. This is our Y. This is our theta. Now we can still draw these in, but we can quickly see a pattern forming, right? When the u's are whole, then we're pretty sure that's gonna be a cosecant curve. But let's just play along. Let's pretend we didn't notice the pattern. We put our ghost sinusoid, that's how I always think of it. It's like a ghost that lives in between. And then we're gonna put dots along the midpoint for it to connect to. But we wanna go up and down. Now we will write the name of this sinusoid, knowing that's not our function, but it's the ghost function, right? So this one is 0.5 for an amplitude, right? So we'll write 0.5 sine of theta. Oh, I forgot the y equals. Squeeze it in, okay? Now, here's what's really fun. We know that cosecant goes with sine. The numbers stay exactly the same. So that tells us that this function is y equals 0.5 cosecant of theta. Sometimes people want to take that 0.5 and like do the reciprocal of it or somehow change that. No, the numbers stay exactly the same. Don't change anything other than the put in the reciprocal function. Okay, so the numbers work exactly the same. And then here's the second part to the second example. Here we go. Zero. Oh no, 10. 10.5, 9.5. Okay, so that's a little different, but we can handle that. That's not a big deal, right? And here comes our curves. Okay. So once again, we have a pretty good idea that if it looks like this, it's cosine and therefore secant, but we're going to draw it out. Not work off our instincts just yet. There are the three matching points, the extreme points. I'll put in my other points on the line just to guide me. And I can see, yep, sure enough, that is a cosine curve, but I have to take into account this, right? It would be y equals the center line plus the amplitude is 0.5, right? 0.5 times the cosine of, it's theta? Yeah, it's theta in this problem. Theta, good. And then to get the green curve, right? That's the orange, that's the ghost function. Again, we don't have to change the numbers at all. We leave them exactly the way they are. So it's 10 plus 0.5. We just switch cosine to secant of theta. And this, I haven't been boxing my answers. They're all the right answers though. That's correct. Let's just go back because, you know, I always feel better. Y equals the cosecant of theta, yes. 0.5, this is correct. And yes. Okay, ghost functions, really cute, really fun. I'm gonna do part B, but you know what? I'm gonna go grab my charger because I got an alert. I'll be right back. Here I am, plugging everything in as we postmodern Americans do. Trying not to make my whole studio fall down, which is a chair on my table. It's pretty technically advanced, but it works. All right, let's pray that's working. All right, so that's secant and cosecant. Now we're gonna do part B, which are the graphs of tangent and cotangent. Okay. They are kind of weird, really weird, but that's fun. Let's look at the first quadrant first. Grab your unit circle if you've got it handy. And let's look at what our values are. We've got 0 degrees here, and then we've got 30, 45, 60, and this will be 90. This is like the first quadrant, right? Now we know that tangent equals sine over cosine. So if we have our unit circle, here's mine, and we have all of our cosine and sine values right here, we can very easily calculate our tangent values. Hang on, one more thing. The sun is getting to be a little bit of an issue at this time of day. What terrible problems we have. The sun is making shadows and we can't cope. I can't cope. You would laugh if you saw what I was doing. I'm not even going to tell you. Okay. So what we can do to find the value of tangent at 30 degrees is go on to our unit circle. There are our values. So sine over cosine would be 1/2 over square root of 3 over 2. We would, to use our complex fractions, we would multiply by the reciprocal, right? And then we would get, simplified, it would be 1 over square root of 3, right? At 45 degrees, at 0 degrees, it's 0 over 1. Again, I'm just pulling that right off my unit circle. There was this one. Square root of 2, over square root of 2 over 2. That is just plain 1. At 60 degrees, it's square root of 3 over 2 over 1/2, so that would be square root of 3 over 1. And at 90 degrees, it would be 1 over 0, which is undefined. Yikes. So we see what's happening here. Five, 10, 15, 20. Okay, at 0 degrees, the value of the tangent function is 0. At this, it is just a little bit higher than that. At this, it's 1. See, so we're just slowly creeping. Here, it's a little bit more than 1, but it's still considerably less than 5. And at this, it's undefined, so it shoots way up. So this is the way the tangent function looks in the first quadrant. Okay? Now, if we look in the second quadrant, so we're going to extend this out. Pretend this isn't here. We're just going to work over the top of it. Let's go to our next set of degrees, which are 120, 135, 150, and then 180. Okay? In these, we're going to have negative values. So I'm going to come down here, right? It'd be -5, -10, -15, -20. All right, we'll do the same thing, but because we have minuses, we notice that our curve is going to be, in the second quadrant, we will have all of these same values, only minus. So our curve will look like this. Well, no, it's not exactly the same, is it? Because the order is different. Let's just go ahead and calculate them. We'll do it the slow and patient way. At 120, it is -1 over the square root of 3. At 135, it's -1. At 150, it would be -square root of 3 over 1. And at 180, it would be 0 over -1, which is 0. Okay? But at 90, it was undefined. So this time, it's going to look like this. It's going to come down from undefined, and then it's going to go slowly through those values as we've marked them out, and then at 180 it will be back at 0. Okay? So what we get, now I'm going to put this all together, right? Now you can see how we got the first section and the second section. Now we're going to repeat that, and you will see what it looks like. Well, I'm just going to show you in the book because it's so fun. Right? We did this first, then we did this second. John did it slightly different than me. I like my way better. But we did this, and then we found out that it went down, and so we put them together. Look at what we get, right? We get this S shape. Here's the y-axis. So it starts at 0 and it goes up, but then it creates this S, this wave, in between these periods where it hits an undefined value. It has a negative component and a positive component. But it creates this really weird S-curve with these undefined gaps whenever tangent is undefined. Wickety wild, am I right? So that's the basic tangent function. And then cotangent works basically the same as our other reciprocal functions, where it's like a mirror image. We have the same, no, they're at different periods, aren't they? Look at that. It switches. It doesn't go through 0 anymore. The periods are now 180 degrees instead of plus or minus 90. And it's in the backward shape, but it retains this same sectioned off by the undefined values. What in the world? Cool, right? So here's our only problem. Sketch the graph of -2 tangent of theta. Let's do that. Y equals -2 tangent of theta. Okay, so we know it's going to have this basic shape like this, right? That's what we're starting with. -2 tells us that we have an amplitude change. Our center line is still 0, But instead of just going up 1, we're going up 2, up and down, right? So what that does is it just kind of stretches out these curves so they're not quite so tight. We know that the cotangent curve has its undefined points at 90 and 270. Okay, and I guess I could go minus 90 right there. That would be helpful. This minus sign, just like with our other curves, it turns it upside down. So instead of going this way, they're going to go this way, which is like cotangent, but that's what this minus sign does. So they're going to go through our wacky little curves here. Are going to have their middle points at 0 degrees and at 180 degrees. They're going to go backwards from the usual way because of that minus. Our amplitude of 2 is going to stretch them a little bit. We're just going to kind of sketch that. We're not going to be real specific about it. So we're just going to show it like this. Wait, I'm on the wrong quadrant. Ignore that. It starts here, right, at the undefined, and it comes down, and it goes down like that. Okay, I like the way this one is a little bit straighter. This one's probably a little curvier than it should be. Okay, then we go up here and we do it again. Go through the midpoint and down the undefined, and then we could start another one here, couldn't we? And have it go like that to the third undefined section. Okay, that is how we draw the tangent graph. It's wild, isn't it? And we also see that negative tangent is basically behaving like cotangent, right? You can see that here. Here's what we said our cotangent curve looks like, but here's our negative tangent, and it's going in the same direction as the cotangent. These are supposed to be a little more stretched out because our amplitude is 2 rather than just 1 as it is here. But otherwise they look a lot the same. We're not going to do a lot more with these graphs, but I'm really glad that we know them because we've been talking about sine and cosine so much. Because of the way sine and cosine are shaped, they're much more useful graphs with lots of applications in real life. The graphs of secant and cosecant, the U-shaped ones, and the graphs of tangent and cotangent, which are the up and down S's, are much less useful. So you don't see them as much in higher mathematics as you do the sine and cosine. They're still important. We still want to understand them, but we're just not going to take them as far as we do these. Lesson 94 is now complete. Yay! Goodbye.